Hello all, in this video we are going to learn about sensor classification. As I told in the previous video series, sensors is classified into three types. First one is passive and active sensor, analog and digital sensor, scalar and vector sensor. So first one is a passive sensor, cannot independently sense the input. So these type of sensors cannot find the input signal on their own. Say for example, the accelerometer, soil measure, water level sensors, and the temperature sensors. So accelerometer is used to determine the speed of the vehicle in two-wheeler or maybe in four-wheeler. Soil measure is used to determine the water content in the soil. Water level, maybe in the water level sensors can be used in dams or in tanks, very big containers. So these are the applications where these types of sensors would be used. The temperature sensor is obviously used to determine the temperature. So these types of sensors comes under passive sensor category. The next one is active sensor. These active sensors independently sense the input. Say for example, a radar, sound sensors, and the laser sensors. So these sensors will respond to the input signal immediately. That is why they are called as active sensors. Next one is a analog sensor. The response or output of the sensor is some continuous function of its input parameter. Say for example, the temperature sensor, LDR, light detecting radiation, uh, analog pressure sensor, analog Hall effect sensor, and magnetic sensor. Magnetic sensors are used to determine the magnetic signals. Pressure sensors are used to determine the pressure in the environment. Temperature sensor is used to find the temperature of the environment. LDR is nothing but the light detecting radiation. It is used to determine the light. So LDR shows continuous variation in its resistance as a function of intensity of light falling on it. Next one is a digital sensor. Responses in binary nature. Digital sensor means either the output will be 0 or the output will be 1. It is designed in such a way to overcome the disadvantages of analog sensors. So, analog sensors are used to sense the analog signal. Digital sensors are the advanced version of analog signals. The disadvantages of analog signals are overcome by the digital sensors. So these examples and applications are the passive infrared sensor, PIR sensor, which is used to determine the presence of human beings, and digital temperature sensor, which is used to determine the temperature. Next one is a scalar sensor. Scalar sensor, from the word itself, we can determine that there is no indication of direction. Vector sensor means there is an indication of direction as well as magnitude. Only if magnitude is there, then we say it as a scalar sensor. These detects the input parameter only based on its magnitude. The response of the sensor is a function of magnitude of the input parameter, not affected by the direction of the input parameter. For example, temperature sensor, gas sensor, strain sensor, color sensor, and smoke sensors are examples of scalar sensors. Vector sensor means the response of the sensor depends on the magnitude of a direction and the orientation of input parameter. Accelerometer, gyroscope, magnetic field, and motion detector sensors are examples for vector sensors. So these sensors indicate the directions also. So it is called as vector sensor. So next one is a actuator. Actuators are usually the devices which facilitates the movement or motion, locomotion in a system. These types of actuators can be either motors or it can be stepper motor, servo motor, DC motor. Usually, actuators are the devices which will be provided with some energy, maybe through uh, wired system or wireless system. We will be providing some signals to it. Move, commands, okay, commands, move forward, move left, move right, or turn towards, take a turn in the left side. So likewise, we will be providing signals to the actuators, and based on that, it will work. So in the next video, we shall learn about actuators. See you in the next video. Until then, it's a bye bye from Radhika.